So what I was hoping to have you do with this problem is that you not expand it all out. So all we're really going to worry about is the 3, and let me change the ink here. So if we were to expand all those terms out, we'd really only have to worry about the leading terms in each, and that works out to be 3x to the 4th. So that's the leading term, and of course it is a 4th degree polynomial. Well, two reasons. One reason for this work I did right here. The other reason is I see that this has this x minus 1 term has a multiplicity 2, that has multiplicity 1, that has multiplicity 1. Those together add to 4, so that means there's 4 possible solutions. And because it's a 4th degree equation, a 4th degree polynomial, we know it, and the ending behavior acts like a parabola. So as x goes out to infinity, y goes out to infinity, and as x goes out to negative infinity, y also goes out to positive infinity. How many turns does it have? I see 3 zeros, so it could have actually I see 4 zeros. It could have 4 turns. It could have 3 turns. What I was hoping you to remember though is that n minus 1. Take the degree, subtract 1. That tells me at most it could be as 3 turns. What are the coordinates of the x-intercepts? So the x-intercepts, we go inside and ask ourselves, when is it equal to 0? So when x equals 1, there's a 0, and that is multiplicity 2 because of the exponent. So that's a double root, a double 0. The next 0 is negative 1, 0, and that has an exponent of 1, so that has a single multiplicity. And the negative 2, 0, when x equals negative 2, that's also 0. That has multiplicity 1. What are the coordinates of the P-intercept? Well, we're basically finding P of 0, because any point along this axis has an x-coordinate of 0. So 3 times negative 1 squared, I'm substituting in 0 for the x's. And then it'll be 1 times 2. I'm seeing 6. So the P coordinate is 0, 6. So for this question, we need to expand it. Basically in standard form, I need to expand this all out. So 3 times x minus 1 times x minus 1. When you see a binomial squared, that means we have to FOIL it. So that leaves me 3 times x squared. We have negative 1x and another negative 1x. That's negative 2x. And then negative 1 times negative 1 is positive 1. Plus 2. I have to distribute the 3 through. So that leaves me 3x squared minus 6x plus 3. And then I have this extra plus 2, which is a like term. So that would be plus 5. So I'm seeing a parabola. So to answer part B and C, I'm seeing a parabola which opens up. So, and I know parabolas look like this. So as x goes out to positive infinity, y goes out to positive infinity. As x goes out to negative infinity, y approaches positive infinity. Okay, the q-intercept is the same as the y-intercept. So I know when x equals 0, that y will be what the y-intercept is. And if I use this form of this equation, 0 minus 0 plus 5 will be 5. The coordinates of the vertex, remember, we're talking about a times x minus h squared plus k, and we have to change the sign of what's inside the parentheses, so the vertex is 1, 2, the point 1, 2. And this is the minimum, because the reason I know it's a minimum is because this parabola opens up, because that leading coefficient is positive. Okay, so min, because it opens up. And then we're going to find the inverse. So I swapped x and y. Now I'm going to solve this for y. I'll subtract 2. So x minus 2, I'll divide by the 3. And that leaves me the quantity y minus 1 squared. I got to remove the square by square rooting. And then I'm going to add the 1. So x minus 2 over 3, I'll take the square root of it, then I'll add 1. And that will be the inverse of this function on that restricted domain. I know I want the positive value because if this is the, let's see, if this is the positive, that's the part that we're doing, and we're switching x and y, that's going to just reflect around that line y equals x, and that's certainly a positive square root. Okay, I think most of you got the height of the building question right. Basically what I'm trying to find is h of 0. If I substitute 0 into that expression, I get 12. What's the maximum height the ball reaches? Well, if this is a parabola, I see that maximum height is the vertex. Where we find the vertex in Algebra 2 and Pre-Calculus is by doing that negative b over 2a trick. So if b is 8, negative 8 over 2 times negative 2. So that will be negative 8 over negative 4, which gives me an answer of 2. So when x equals 2 seconds, that ball is at the biggest, tallest height. So then I'm going to find h of 2, which is negative 2 times 2 squared is 4, plus 8 times 2 is 16, plus 12. Well, that'll be negative 8 plus 16, which is 8, plus 12, which is 20. So that ball is 20 feet up. It is measured in feet. I guess we aren't told. 20 units up at 2 seconds. When does the ball hit the ground? Well, basically we're solving this equation for 0. Now at this point, this is a quadratic equation. We can use the quadratic formula, or we can use a quad 83 on our calculator, which is the way to find. You just use the quadratic formula with software. And as soon as I find my answers here, here we go. Well, I did it with, I guess I never did actually do it with a quadratic, finish it out. What I did get when I did the quadratic formula was 2 plus or minus the square root of 10. I'm going to ignore the negative because I only want positive time. So 2 plus the square root of 10 is, let's see, is about 5.2 seconds. So what I was really looking for is I wanted to see something where you're saying the height is equal to 0. You could either have written 0 equals that expression or h of t equals 0. Both work. Use a quadratic formula or quad 83. It's acceptable at this point. Notice I didn't write quad 83 on this. Okay, so I'm seeing a polynomial. So I know it's not a rational function. It's a polynomial. I'm seeing a double root at x equals negative 1. I'm seeing a triple root because it is wiggling through. So at x equals 2, it's a triple root. And I see a single root at x equals 4. I see it also opens down, but we'll figure that out in a minute. So I know y equals some stretch factor probably times x plus 1 squared, that takes care of the x minus 1, times, I'm going to rewrite this down here, y equals a times x plus 1 squared. I see a triple root at x equals 2, and I see a single root at x equals 4. And if I substitute in 0, do I get negative 4? Hardly. So, negative 4 equals some number a times, now I'm substituting in 0 for all those x's. So 1 squared times negative 2 cubed times negative 4. Well, that's going to give what? Negative 4 equals a times, let's see, well, at least that's 1. That's negative 8 times negative 4 is positive 32. So A equals negative 4 over 32, or negative 1/8. And I'm glad it's negative because that confirms why this parabola opens down. So to write the final answer, I'm going to write y, or f of x, equals negative 1 over 8 times x times x minus, or plus 1 squared times x minus 2 cubed times x minus 4. So for this rational function, I see a vertical asymptote at x equals negative 3, so that'll be x plus 3, that goes in the denominator. I see another vertical asymptote at x equals 1, so that'll be x minus 1. And I also notice that it is acting like 1 over x squared, so I'm going to square that. I see a hole in the graph at x equals 2, so that's not an asymptote, the vertical asymptote. That's just a common factor on the top and the bottom. So x minus 2 in the denominator, x minus 2 in the numerator. I am seeing a triple zero at x equals negative 1. So x plus 1 cubed. I'm also seeing a polynomial that has the same degree in the numerator and the same degree in the denominator, both x to the 4th. So that tells me it does have a horizontal asymptote. And I look at this graph, I see it has a horizontal asymptote of negative 1. So that goes in the front, and that should graph that function. Okay, so this function here, I see an x cubed in the bottom, I see an x squared on the top. That tells me it's a bottom-heavy rational function. The denominator is going to grow faster than the numerator. The horizontal asymptote is the line y equals 0. For this function here, I see 2x squareds, and that means it's the same degree, so I'm going to take the coefficient of the ratio of the coefficients, which I'm seeing as y equals negative 1/2. So it's the same power, same degree in the numerator and the denominator. That tells me there's going to be a horizontal asymptote, and there it is. What are the coordinates of the X-intercepts? The X-intercept is the zeros, and that's where it happens on the numerator. So I see a 0 at negative 3, because negative 3 plus 3 is 0. I'm seeing another 0 at positive 1. J-intercept is the same thing as the Y-intercept, so I'm going to drop in. I'm basically finding J of 0. That gives me 3 times positive 3 times negative 1 all over negative 2 squared, which is going to be 4, which is going to give me the y-intercept or j-intercept of 0, negative 9/4. The vertical asymptotes happen with the denominators equal to 0, so that's x equals 2, and notice that it acts like 1 over x squared, so when I'm graphing it, I'm going to have to think about that. I'm seeing the same degree in the denominators I see in the numerator, both x squared, so it has a horizontal asymptote of y equals 3. More than a couple of you missed these next two questions. If there's a horizontal asymptote, that tells me the long run behavior is that horizontal asymptote. So as x goes out to infinity, y approaches 3, or j of x approaches 3, and as x approaches negative infinity, j of x also approaches 3. So now let's do some graphing. I'm going to put a dotted line for the horizontal asymptote. I'm going to put a vertical line at x equals positive 2. I'm going to put in a 0 at x equals negative 3. I'm going to put in a 0 at 1. I'm going to put in a y-intercept at negative 9/4, which is a little bit better than negative 2. I know that these are the only zeros, so that tells me the graph has to cross there. it has to go through that point. So I'm thinking this graph looks something like this, and it follows out, heads out to follow that asymptote. And since this is supposed to act like 1 over x squared here, it has to go like this. I also know it's not going to come down and cross the x-axis because there's no more x-intercepts. There's only these two that I'm dealing with. So I think that's a pretty accurate representation of what this graph looks like. Also, for these last two questions, which I made for the honor section, I decided to use, it doesn't say use long division, so for this first one, I decided synthetic division works even easier. I did notice that I didn't have an x to the first power, so notice I put the 0 in. And then bring down, I pulled the coefficients off. I remember x minus 2 equals 0 is what we look for. So x equals, when you're doing synthetic division, you say x, let's see, let me get my pen back here. So x has to, x minus 2 equals 0, so I'm going to write x equals 2 there. And then you just run through the synthetic division. It doesn't say anything about finding the quotient and the remainder, so I left it in this form. If I wanted to do that, I could write 3x to the third, remember it's 1 degree less than we start with, plus 4x squared minus 2x minus 4, with a remainder of 7 over x minus 2. For this next question, I decided to use long division since it is a quadratic in the denominator. And what times x squared is x squared? Well, 1. I plugged it in, changed the signs. I'm left with just x. 6x, there's nothing I can multiply x squared by to get 6x. Well, there is, but not a polynomial kind of situation. So that's the remainder. That's why I wrote 1 plus 6x over x squared minus 3. And they aren't asking us to do anything with this, so I won't. So hopefully that helps you do the test. If you want to do some live help, feel free to come grab me.